So we go to question 3. Question 3 we have the probability of a person catching a particular disease when exposed to 0.2. When exposed to it. When exposed to it to 0.2. If the person is inoculated against the disease, then this probability rises to 0.9 if the person has not been inoculated. So if 70% of the population has been inoculated, what is the probability that the person who caught the disease when exposed and been inoculated? It's a very simple tree diagram question. So first thing, you start with the population. 70% in probability, if anything is given in percentage, you divide 70 by 100. So we'll get 0.7. Since probability ranges from 0 to 1. So now we are talking about the population that has been inoculated is 0.7. And then, meaning that since the total probability is 1, for the whole population, we have 1. So it will be 1 minus 0.7, which is 0.3 for those not inoculated. So that what we have now is, when you go to a tree, is a branch for those inoculated and a branch for those not inoculated. That's the first thing, population. For the population, you go to the probability of a person catching a particular disease when exposed to it is 0.2. If the person is inoculated, so you go to the inoculated, these are inoculated. These not inoculated. So if the person has been inoculated, the probability of catching a disease is 0.2. So inoculated, catching the disease, 0.2. So we don't care about not catching. So not inoculated, catching the disease is 0.
So he's saying you want.
So again, here you don't care about the other one. Then now the question is saying, what is the probability that the person who caught the disease when exposed had been inoculated? So this line, the person inoculated and got the disease. So we say the probability that the person who caught the disease has been inoculated is equal to 0.7 multiplied by 0.2. So we get 0.14. That's how you're obtaining from probability from the tree diagram. Okay. So if the question asks that, what is the probability that the person who caught the disease when exposed it was not inoculated, I've used the downline. Hello?
Sir, I repeat on the arrows that you made on the
Diagram.
The diagram.
Diagram.
The diagram.
The tree diagram, we have two categories here. The first information given is the probability of people catching the disease. Now, those people are in categories. The first category is inoculated. The other category is not inoculated. So if you want to talk about the probability of somebody catching the disease, you first need to know the factors around that person. Has the person been inoculated? If yes, the probability of them catching a disease is 0.2. If not inoculated, the probability of them catching the disease is 0.9. That is if the person has not been inoculated. So you first go for the population. How many people do I have? So we have 0.7 inoculated, 0.3 not inoculated, so that total 1. From there, of those inoculated, what is the probability of them catching the disease? It is 0.2. Of those not inoculated, what's the probability of them catching the disease? It is 0.9. The question is saying, what is the probability that the person who caught the disease when exposed had been inoculated? So the person, these are the people. Probability of catching when inoculated, 0.2. So you multiply the population inoculated by the probability chance of them getting the disease. That's why I've gotten a product with you.
Now, sir, there is no any use of calculating these other probabilities for the remaining branches like this one for catching the disease with the inoculated.
There's no need. But even if you get them, they won't help. Probability can be expressed in decimal. Yes, fractions are decimal. Next thing that follows from ordinary fraction is a decimal.
So when you're given in this form, it's to always multiply, right?
Yes. In most cases on the tree, we multiply. Because 1 is the total probability. Why are we separated from 1? 1 is the total probability, so you got 1 and factorial it out. When you bring everything in the decimals.
So what do you mean by it's 1?
So somebody has asked the question to say, why have we subtracted 0.7 from 1? So since we said that the total probability is 1, if you have n probability, you subtract from 1 to get the remaining. So in a population, you only have two things. Some people are annotated, others are not. If you are told 0.7 annotated, then the remaining ones are not. So how many are remaining? 0.3. Since our total should be 1. Question 4. A bag contains 12 eggs, of which one is bad. If if 3 eggs are selected at random, what is the probability that one of them will be bad? So if I have this as a bag, and a bag. If I have this as a bag, this is a bag. Then I have eggs inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This guy is bad. So I have 12 eggs. 1 is bad. So the bad one is put in black. What is the probability that if you pick 3 from these eggs, one of them will be bad? If you want, you can go to a tree and find the probability. Or you can avoid the tree, say, okay, the probability of 1 out of 3 being bad is equal to. So when you're picking eggs, in this context, we're assuming that the picking, you pick 1, then you pick again, then you pick for the third time. So picking 3 eggs. So when you pick the first one, you pick this one. The time you're going to pick the first one, you have 1, so now the thing is this. If I'm going to pick the white ones, the first one I'm going to pick, I have 11 white ones out of 12 eggs. So if the first egg I pick is white, then there will be 11 possibilities of me picking white out of 12. I've just picked 1, but I need 3. So I'll go back and pick again. If I pick the same white, I'll now find that the white are 10 because I've picked 1 out of 11. So now they are 10. And the total, because 1 is out, the total is 11. So far, I have 2 eggs. They are all white. But in these 3, I need 3. In these 3, 1 must be bad. So now I go back. I'll find there how many eggs? There are 10 because I've removed 2. Now in the 10, there's only 1 which is bad. So if I'm to pick it, there's only 1 out of 10 chance of picking that one. So these are multiplying probabilities. This is just one way where you pick in that order. I can also pick in this order. The first one is white, second is bad, the third one is white. Or the first one is bad, and the second is not bad, the third is not bad. Now we have put this combination. So if you go for the second one, in probability, now you're giving an option. So to give an option in probability, you say or. So when dealing with numbers, then you're going to have plus because you said or is addition, which is still union in sets. So or I've added, I go back and pick.
Sir, why not 9/10?
The 9 is the white.
11 over.
But you're picking black.
No.
And you only have 1 black. Or the first one is white, 11 over 12. Multiplied by the second one is black. You only have 1 black, so 1 over 11. Over 11 because you have already picked in the total. Then the third one is white. So now again there are 10. But all the 10 in the box are white, so 10 out of 10. Or the third one, the first one you pick is black. Then the second is white. Then again, white. As you can see that these numbers are canceling each other here, just remaining with at each point. This 10 and this 10 will go. This 11 and this 11 will go. So at each point, I'll have 1 over 12 plus this here, this here. I have 1 over 12 again, plus this here, 1 over 12. This is 3 over 12, which is 1 over 12. Hello.
If on this one you are picking, and then when you pick, you are not returning that egg again. What term is it used to differentiate like this? That probability that you pick and then you return it back. You pick again. Like the number of the denominator, the number that will not be changing. What term is used to differentiate the two? Like in this case, I'll pick and I'll not return. And then
if you don't return, you say pick without replacement. There's no returning. Pick with replacement, there's returning.
In this case, which term did you use to identify that you are not replacing?
The language, a bag contains 12 eggs, of which one is bad. If 3 eggs are selected at random, so you select them out of the box.
Trying running me through. I was logged out when you were explaining this.
So we have okay, all those with queries you can ask so that I attend to them at once.
I think I missed the point you said why it's 1/10 instead of 9/.
Another one.
Sir, me, I haven't followed where the 11 and the 10s are coming from.
Another query. Okay.
So, is it possible that you can swap the arrangement of choosing? Like you start with the bad, then good, good, or good, bad, bad.
Okay. We still have the same arrangement. And they're all here. So what you're saying, the question is saying that there's a bag that has 12 eggs. And you want to select 3 eggs from that bag. What is the probability that one of those eggs that you're selecting will be bad if there's an egg which is bad in that box, in that bag? You have 12 eggs, one is bad. That's a known fact. You want to get 3. What's the probability that in those 3, one will be bad? It's about how you are selecting those 3. If I have 12 eggs and I get 1, how many eggs are remaining? 11. So that's why when you get 1, you remain with 11 down. The first time you go to get, there will be 12. Then you get to remain with 11. Because you have gotten 2 now, you remain with 10. The numbers on top, we have 11 eggs that are not bad. Since we are told 12 eggs are in the bag and 1 is bad, meaning 11 are not bad. So if the first time you go to select an egg, you select one which is not bad, you have 11 chances of getting an egg which is not bad because there are 11 eggs which are not bad. That's why we have 11 in the first spot. If you go back and get the one which is not bad again, you would have already gotten one which is not bad. So you go back and get one which is not bad. So now you won't find them 11 because 1 is out. You find 10 which are not bad. And the total of those eggs will now be 11 because 1 has already been taken out. That's why we have the 10 here. The third time you go to get, since in 3, 1 egg must be bad, it means that your third one will be bad. The probability of you getting that bad one is 1 out of the total number of eggs that you have in that box because there's only 1 which is bad. So you can't have 9 here because you must have a bad one in your 3. So you select 1 which is bad, and because it's only 1 out of the remaining eggs in the box, so you have 1 out of 10 because you have remained with 10 because 2 are already out as you pick the third one. Then you switch the order. You switch the order. You select the first time from the not bad one, 11 out of 4. You go back and get the one which is bad, 1 out of 11. You go back and get one which is not bad. There will be 10 because out of 11, you've gotten 1 the first time you picked. So now you find that there are 10 which are not bad, and they are the only ones. Then you go to the third option. It's about the order. So you pick the one that's not bad first when they are still 12. Then they have remained 11. You're not picking from which are not bad, but all the remaining ones are not bad. So you have 11 chances of picking what's not bad, and then 10 what's not bad. Then you simplify, you get 1/12, 1/12, 1/12.
So why wasn't it 10/12 on the previous one? Like on the other one?
So we have 3, which one?
Since there is the 11/12, the 10/11, and 1/10.
Mhm.
And then why wasn't it like 10/12? Since they are reducing when you pick.
So because they're reducing, 12 can't be fixed. So why should we have 12 when they have reduced? So if they have reduced, then this number has to be affected. So by the time you're getting to 10, you should have picked maybe 2 out of 4. Okay, so you can log out and come back first. That will do the other process.